I haven't gotten a haircut in 2 months because of obvious reasons.
Well, that's
But
yeah. I had
that's okay.
fortunately just been to the barber like a couple days before quarantine started, but it's getting on now.
Hmm.
At some point, that won't be as useful as it was.
I mean, like right before, I was like, I really need to go get a haircut, and then now everything's closed, and so.
Yep.
Oh.
So, Redify, I don't remember your name, but I just wanted to warn you that I was recording you. So let's see. I guess I'll pull open your PR and share it.
Yeah, that works. I have it open, so we can go through.
Or you can share it either way. Let me get a recent checkout in any case. Okay, let's try sharing this. You all see that?
No.
With the right code? Yeah, it is.
Yep.
Trying to think what, maybe Jack, you have some thoughts on where to start.
Yeah, so let's see. Without going through individual things yet, just an overview. As I said, I think it's pretty close. I looked through the comments that you made, Nico.
I'm gonna make a paper or a HackMD or something.
That'll work.
By the way, keep going.
So yeah, so I looked through the comments that you made. The biggest one that seems like we should do, but I don't know if we should do in this pull request, maybe even a precursor to this one would be to actually rip out the domain goal and all the like old structs and stuff that were used for the old integration that are still kind of laying around and sort of deeply embedded into some things, or so it seems. But
you mean like the domain goals, right?
Yeah, domain goals, where clauses, program clauses. There's a bunch of structs that like sort of mimic the Chalk engine, or I guess it's Chalk IR structs that look like they can be just removed because they don't seem to be important for anything else. But the problem is, or at least what I'm having trouble in right now, is sort of the boundary is a little bit difficult. So I don't know if you want to go into specifics now about that, but at least before we do that, we need to do a little bit of refactoring around, but that shouldn't be.
Yeah, maybe it's worth just real briefly mentioning, because I don't know if everyone has the context, that there was an older integration of Chalk and rustc, but it was done at a different level. So it was sharing just the Chalk engine and not any of the other code in Chalk. And so we're now trying to sort of, that got ripped out recently, and we're trying to kind of add back in, but doing the integration at the Chalk solve level so that Chalk is actually defining the rules, because before we basically had a copy of all the code in Chalk solve but in rustc. And that's where these structs came from and so forth. But yeah, I think we should rip them out. I mean, are they there on master?
Yeah, they're there. They were never ripped out.
So they survived the removal, but they're probably not used for anything, I guess.
Yeah, so there was one place that it seems like it's used, but I don't think it actually is used. It's just, let me see. I spam one place that the domain goal is pushed somewhere. I don't know. But no, for the by and large, they're not used, so they can be ripped out.
Okay. Yes. So that seems like it would be nicer to not have them.
Yeah.
The,
Yeah. So like I said, I think it's completely doable to rip them out. Like I said, the only thing with the current sort of implementation is the query that's passed to the rustc traits crate is canonicalized. And that's canonicalized in the chalk fulfill file, but it's canonicalized as the that environment. Yeah, so let's see.
Maybe we should just walk through like the like start by just walking through where all the pieces are. That seems like it'd be
yeah, so probably the first place to start would be in librustc trait selection chalk fulfill.
All these things got moved around recently. Not yet.
Yeah, I mean, in the worst part, it's all got moved around after I started the pull request. So I've had to refactor moving around thing or rebase moving around things 3 times. So that's been fun. But anyway, so this is for the most part where things start, where the queries start, and it mimics or is the counterpart to the fulfill file, which is the non-chalk trait engine.
Right.
And then, so the main part, or what actually calls out into librustc traits, is if you go down and select where possible with the evaluate goal.
Right. So the context for folks who aren't as familiar, right now, the way we did the integration, there's this trait that is like the trait engine. It's normally the rustc one. Sometimes it's chalk. It lets you accumulate things that have to be true. That's what register predicate obligation does. This has to be proven. And then select all or error will say everything has to be provable now, or else you should report an error. And select where possible says go try to prove whatever you can and remove it from the list of stuff that needs to be done.
Right.
Okay, so select where possible. Right. So this will go through, pull an obligation out of the list, canonicalize it, storing in this is all the rustc data structures basically. And then it invokes this evaluate goal query.
Right. So
what is it?
So yeah, so that's in librustc traits.
Good guess for Rust Analyzer there. Off the code to jump to. I think that only works because Rust Analyzer falls back to grep or something.
Yeah, I mean, it works for me like 70% of the time, so I'm good with it. But right, so relevant to pulling out domain goal and related structs. If you want to go back to the chalk fulfill file, so sort of important here is the in environment struct, right? And specifically the obligation environment. So if you want to go up on the file, when the obligations are registered, they're actually lowered and stored in the lowered form. But it's not exactly the exact same lowering. It's actually the old lowering. Right.
So that's what this in environment does. Okay.
Right. And this is sort of, we were talking about at one point, you had mentioned that there used to be, I guess, problems with actually constructing the environment, or that had to be resolved. And that's never got pulled out. So that's all still sort of here. And then it calls the environment query.
I see.
Um,
This is the,
yeah, so I think we want to actually rip all these out with domain goal because they're not used elsewhere. The problem is these are done pre-canonicalization, and then they get canonicalized, and then in the chalk mod, the library traits, we're actually calling chalk with the pull request. We're now actually sort of because we're deeply and eagerly lowering, we convert the params to placeholders and such, and that's all done post canonicalization. So we can't just one-to-one use chalk IR environment instead of the rustc environment
well,
right
but this
now.
is a pure function of the def ID.
Yes.
And it never contains, it should never contain, let's see, it might have references to type params and so forth, I guess.
Yeah,
It
so it has references to params, and then the one that I ran into most recently was the free regions.
Mm-hmm.
And I guess we sort of should decide whether or not we want the quote unquote lowered into chalk IR environment to be able to contain those, or if we want to sort of eagerly lower or like convert those as we've done sort of elsewhere. And I think we probably do want to eagerly convert those, but we sort of have to be careful about when we do it in regards to canonicalization.
Eagerly convert, which thing are you referring to?
Params to placeholders, and then yeah, I think that's really the one.
So currently you're converting the params to things in the root universe, right? Placeholders in the root universe.
Yeah.
Okay. So just thinking of it, I guess that longer term, we probably do want to do this pre-canonicalization because I think we sort of a digression, but the way that canonicalization in chalk works is it only replaces inference variables with like bound regions, right? But canonicalization in Rust C replaces both placeholders and bound variables. And if you think about it, it actually makes a lot of sense because the goal of canonicalization is kind of to, among other things, avoid doing essentially equivalent work twice. So if you have, differences that don't make any difference to the end result, you want to try to eliminate them. And it won't matter if we had two placeholders that are in the same universes, they're both in the root universe, and one is called A and one is called B, like it doesn't make a difference. So we would prefer to normalize them to to a consistent thing. And chalk, of course, also goes further than does universe normalization, which is sort of separate but related. So the reason I bring this up, of course, is that we would probably like to have, if we're going to be canonicalizing and the environment is going to reference placeholders that might also appear in the goal, which it might, then we would want to canonicalize them at the same time so that they get the same number and everything works. And so that seems to imply we would prefer to create the, like, rather than pass the def ID. You could imagine passing the def ID to the query along with the goal to be proven, and then constructing the environment. But that's probably not the ideal thing because we'd rather do it before. What I didn't quite understand is why can't you use the chalk structs? Like, why can't we just rewrite this query to use stuff from chalk? Or can
I think we can. I've been playing with it, and I think we can. It's sort of, I'm sort of degeneralizing some of the code right now to make it more amenable to moving things around. But I think we can. The only thing is there's some things that weren't showing up in the post-canonicalization structs that are in the pre-canonicalized form, like the pre-regions. So I just have to write the code to handle that.
Yeah, free regions are basically the same as primes. Or you should be seeing, let's see. Well, we can briefly look at the region kind. Why didn't this find it? Region kind. Okay. It's annoying.
Oh, you deleted the hash at the start. Oh.
Did I put a dash?
No, you deleted the hash.
Oh, there we go.
Yeah.
What is the hash? I didn't even know that was something I could delete. Okay. Okay, so yeah, so RE early bound is exactly like typram, and maybe you're already handling that.
Right.
But the RE free is, yeah, basically the same also. By the time you see it, it's some named life parameter that is free. So yeah, I think you can.
It doesn't show up in the canonicalized form, though. I don't think. At least it hasn't shown up so far.
That's because the canonicalizer. Well, actually, why? It might be replacing them. I don't remember what this does. Where is it? So it looks like, yeah, I don't know why it wouldn't show up there because it at least appears that we pass them through. I think they should be eventually replaced with a placeholder, actually. Like rustc has this distinction of, placeholder-like things that the user declared versus ones that came out of higher rank stuff.
Yeah.
We're treating them differently, but I think that's just less efficient.
Yeah. But yeah, so I guess long story short, yes, I think we can just lower to the chalk IR forms and then just canonicalize that. But then we also, I don't know how different the chalk IR canonicalization is going to be compared to rustc canonicalization, at least in terms of if it's going to change anything.
What kind of things are you concerned it might change?
Well, okay, so I mean, right now, the canonicalization is done by rustc, and then we're lowering the canonicalized form. But if we lower pre-canonicalized and then do the and then if we lower pre-canonicalized and then canonicalize and chalk, I guess the biggest thing that I'm worried about is maybe the placeholders, if they're treated differently. Because I guess right now, I am assuming that they don't.
think you need to care about this very much. Like, I think if you... Okay, wait, hold on a minute. Maybe what I'm saying doesn't make sense. So when we... I think I see your point. If we put in build the chalk data structures here and put them in this goal, then the Rust canonicalizer has no idea what to do with them because they don't implement Rust traits.
Right.
Okay, I see.
And I mean, theoretically we could canonicalize with chalk instead of Rust. I just don't know. Like I said, the biggest thing now that you brought it up was placeholders, because if rustc changes the placeholders, then chalk wouldn't.
Maybe we should, for the time being, I mean, I think for the time being, we could also thread the def ID through there. Or to put another way, this logic converts from the parameter. Like we could use, instead of making this evaluate goal query take an environment, whatever it is, right? It could take a param and.
Yeah, so I did try this, or have been trying this. And the problem that you run into here is that whenever librusc traits the environment lowers the param, it actually generates new clauses too.
No, I wasn't going to say you should lower the param directly. Unless that's what you were, was that what you were suggesting? I was just going to say that we can basically just send the canonical obligation through to this query as is. That's kind of all I was going to say. This evaluate goal, like all in rustc terms. And it gets to the other side. We instantiate it. Now we have an inference context. We have a query. And then we can run this code only producing chalk structs. And there's no more canonicalization because that's all like on the chalk side, essentially.
Oh, I see.
Now, whether this code, sorry. So we would just pass the canonical obligation essentially through here. This would have an obligation, a standard obligation, which has a param and value.
Yeah, and this is what I was saying is, so if you pass the canonical obligation, whenever, at least right now, when and this could be changed, but at least right now, whenever we lower, the code to lower from the obligation to the old environment generates new clauses. So I guess I just have to port the same lowering, but in chalk terms.
You would move that code into here.
Yeah, which is fine.
Right.
I can do that.
Seems more like where I would expect it to be anyway, to be honest.
Yeah. And I think that's where I was sort of heading as I played this.
I'm a little bit, now that I look at this again, it's probably correct, but maybe we should walk through what this does. I'm a little bit leaving aside the environment question.
Yeah.
This doesn't do what a lot of things do when they get a canonical goal or a canonical thing, which is to essentially create an inference context and instantiate that thing in that inference context. There's not necessarily a reason to do that. It's interesting though. So it's sort of mapping directly from this canonical form to the chalk's canonical form, I guess.
Right, but that sort of makes sense because it's instantiated on the chalk side, and chalk takes the canonical or a canonical role, right?
Right.
So
yeah, they don't
I
share
guess
the same like Well, let's see. Then you hit some of these limits, like this placeholder business.
Right.
But that probably won't be a problem for us for a little while. Sooner or later, it might. Okay, so what this code is doing, it gets, let me make this a bit wider. It gets this canonical, this Rust canonical version. It's going to try to create a chalk canonical version by going through all the bound variables, mapping them. So here's the Rust thing. It's just going to create the equivalent thing in chalk. Seems fine, I guess. This is a side note that we probably have to add this concept to chalk, I suspect.
Right.
Gotta put that on my list.
Yeah, that's actually, it causes a few tests to fail that used to pass, or at least used to in the old integration, regarding like knowing that int and floats are sized is one, and then also like knowing that a float is like one of two impulse could match and one's a float, whereas the other would not be.
But the old integration didn't have floats, right? Or did it?
Say again?
The old integration didn't have floats, or
yeah. So the old integration used all Rust types. So the old integration did use the floats in. So the old integration
context and everything else.
Mm-hmm. Yeah.
Right.
So then we create. So then we create the environment, which you're going to lower into. Okay, and this converts from the rustc's version of chalk's data structures into chalk's version of chalk's data structures.
Yes.
And then we're going to lower. Interesting. This is doing the same thing, but now we're going from rustc's notion of a goal to chalk directly to chalk's notion.
Mm-hmm.
Okay, so yeah, so the other way we could do this is we could create our inference context. You could instantiate this canonical thing in it. You could build a chalk term that's like, you could even create a chalk inference context as well. Build a chalk term that is equivalent. So where there's an inference variable in rustc, we make an inference variable in chalk, for example.
Mm-hmm.
Run chalk canonicalizer and get like the same behavior. Wouldn't be very efficient, but it would work. That would then eliminate these problems, I think.
I don't think these are problems. I think they're just unimplemented, but I think we can lower the placeholder tie and placeholder region, and then I guess eventually placeholder const just as placeholders.
Well, these are like, this is indicating that the nth variable is a placeholder tie, right?
Right, and
so,
I think, I see.
So you could remap the variable. You could like flat map them out and then remap the variable numbers, but that's kind of annoying. Mm-hmm. Or we could extend chalk to also canonicalize placeholders, which is probably what we should do actually. And then there's a direct map between the two. You don't have to have any mismatch.
Yeah.
Probably that's just the right answer. We just need to extend chalk with placeholders. And then that's fine. Because otherwise, yeah, it seems elegant to be able to go directly into, between the two canonical forms.
Mm-hmm.
I'm just wondering now if we are passing the premenv. Well, if we're going to build the chalk data structures directly from the premenv without any canonicalization step, I think that will work out fine for now. Because the reason it'll work out fine is the only things that the parameter environment and the goal might share are these root placeholders that like the generic types and things that are in scope. And for now, we map them. They don't map to canonical variables, right? They map to just like placeholders in the root region or whatever. root universe. So, because otherwise, if they had two things in common, you would, and they were going to get canonicalized, you would want to make sure that they are the same number, right? See what I'm saying?
Yeah. Yeah, I think for now this works. We'll have to sort of play with it as we go. Time check, we're half an hour in.
Yeah. So I guess I'm just wondering whether, like, the other option is to say, so we have Rusty's version of domingle and Chalk's version of domingle, and it lets us keep the code the way it is, and we land it, and then we try to remove it, like it doesn't block landing.
Right. So removing it doesn't block landing this pull request, but I also don't think it's too hard to remove for the future, or I mean, depending on how long this takes to land here. So either way.
Yeah. I think, okay, let's keep going and we'll think about it. I don't think it needs to block personally. The code's already there.
Mm-hmm. So maybe we should just finish up with this evaluate goal function, and then we can talk a little bit about lowering.
Yeah, that sounds right. Right, so it creates the lowered goal, invokes the solver, creates a Rust database that can give to the solver here. This may be where things get a little interesting, and then we have to convert back to the solution.
Right.
And that means we have to do a certain amount of converting back from chalk types to Rusty types, which is a pain.
So right now, at least with the test we have, the only converting back that we need is ints. I don't even think we need floats. So right now, it's really minimal. What is there? It's going to get more difficult and more complex once we start thinking about if we have to return like a param. Because then we sort of have to distinguish between, I guess it's sort of already distinguished by the universe, but like a placeholder that was converted down from a param versus a placeholder that was already there.
I think we should not do that. Actually, no, we can come back to it. I'm resisting talking about the environment again. I think we should probably work more towards, like, the goal was that Rusty types have a chalk counterpart and vice versa, and there's like just a simple map between them. In other words, that the actual interned tie is a Rusty type.
So this may be
work towards that goal, and then their snapping is just not a mapping.
Yeah, agreed. And right now, it works for the minimal implementation that we're putting in. Let's see what else. Yeah, I mean, a lot of the mapping back is unimplemented macro, but that's okay because we don't need it right now.
It occurs to me that the environment, there's one other twist we didn't talk about, which is that we could, like, we have to look at what exactly the chalk environment is that we're building that's slightly different than the Rusty one, because it's got a little bit more of implied bound structure and stuff. But if we can express those in Rusty predicates, then we could build the chalk one in Rusty terms, right? And then lower that, canonicalize it with Rusty's canonizer, and then lower it. And we only have one concept of lowering, at least going from Rusty to chalk, and not Rusty and Rusty chalk prime to chalk.
Yeah, that's also possibly doable. I would have to look to see. I'm not as familiar with the rustc predicates to know whether or not we can do that, but probably
I think
could.
it's doable, or at worst, we could add a thing in there. But I think that's more the path I would go, but I don't think we should do it to block the.
Okay. Awesome. All right. So do we want to move on to lowering and sort of go through this?
Yeah, let's look at the lowering code. So there's this trait lower into. It's kind of just into that passes an interner, I guess.
Right. Right. So let's see. Starting at predicate. So most of this makes sense for predicate trait. Region outlibs and type outlibs, we've already sort of talked about in the meetings, but right now that just lowers to an empty goal set, so it'll always be true. So that's fine. Projection sort of makes sense. Well-formed, this I sort of copied the old code a little bit for lowering well-formed for now, but I think this will eventually, or it not I think, but this will eventually just be handled by a chalk solve.
Right.
So this was sort of working, but these will just be not here.
Yeah, so that's something, well-forminess goals for built-in types is something we can add to chalk soon. Like we've got all the parts there.
Right.
We're almost got the parts there.
Yeah, so
then
this
it would
is
just be this line, basically, is what you're saying.
Yeah, so it'll be super simple. And then the last bit here, object safe, closure kind, subtype, and constant value.
So I think we want to add subtype to chalk, and I was gonna ratify. I was gonna ping you about this as a possible topic and leave out some instructions for what, because among other things, chalk's notion of type equality is actually wrong. Like it doesn't handle higher rank things entirely correctly, and I think the only way to do it is by porting the subtyping code. I can show some examples, but it comes out because of just functions and variance is annoying. So that I think we'll end up porting. Closure kind, yeah, we'll figure it out. I kind of think closure kind, I forget how I wanted to deal with that. So that tells you whether a closure is fn or fn mute or fn once, and it's something we don't know right away, but we figure it out later. And I guess you could imagine adding facts into the environment when you do figure it out at that phase of inference, or I don't know, maybe we'll add a callback. I'd rather do something clean than not clean. So we'll have to see.
Yeah. Yeah, we can definitely look at these later. Right now, it's not blocking anything, so yeah.
Object safe we might end up, just to keep ourselves sane, I could imagine adding that as a flag to a trait datum or something like that. And keeping it so that rustc still has to do that computation, which just tells us yes or no, it is object safe or it's not. But you have to look, because I think, those rules are a little bit tricky. Anyway, okay, it's fine like this for now.
Right.
We probably could even panic there, maybe not panic.
I think I tried panicking at some point, and subtype is used.
Subtype at least will definitely be used.
Yeah. The others, I think we can panic for. I haven't seen them yet.
I think they will come up, but not for the kinds of examples we're starting with.
Right. Trait predicate, polytrait predicate. These seem out of date. Maybe. I feel like I changed these. Maybe not. I don't know.
Trait predicate is actually probably more mappable to a goal than a trait ref, like a domain goal.
Right, because it has the binders.
And it has the, if I recall, it's used, it kind of has the semantics of a trait ref that I have to prove.
Right.
It's a trait predicate. Right.
Right. So I think those first two are maybe unused at this point. I would have to double check. But
Maybe
these should all, yeah. So I think it's just that third impl where polytrait predicate gets lowered to goal data.
Okay.
And so, yeah. So for the most part, this makes sense, I think.
How are you handling, let's talk about bound things.
Right. So this is, yeah, I was going to mention that. So this is where
Okay.
the collect bound bars.
I have to say, I love these hints.
Oh,
Sometimes
yeah.
they make me miss. They're really great, except when I'm like, I just don't even see this code because it was so far off to the right.
Yeah, the only thing that I find I don't like about it is whenever I'm trying to like rename the variable and it goes to the last character, but then skips the hint.
That plus I really want to control click on them, like a lot. I'm like, oh, I want to go to trait predicate type. No, that's not a thing.
Yeah, that'd be nice. But yeah, so maybe we can come back to collect bound bars after we just go through the lowering, because I think the lowering code is fairly simple, but I think we should maybe just go through and make sure we at least get through it. So projection predicate, more or less the same thing. Makes sense. Poly projection predicate, same thing. Environment. Yeah, so this will, I think,
this might go away, I guess.
Yeah, this might go away at some point, but it's more or less a one-to-one mapping.
Same here.
Same.
These are converting between the rustc version of chalk data structures and the chalk versions of chalk data structures.
Same thing. Domain goal. These, for the most part, make sense, but this is not. Yeah, I think I don't know if these are even used. I think the ones below. I need to go through and clean up a little bit because a lot of these were sort of early implementations. Yeah. Maybe if you want to go down to that. Yeah, so this is where it sort of, yeah. These are some of the code that we might remove. This is probably the biggest one or the most important implementation to talk about is the lowering for ties. So right now, these are more or less one-to-one, where each tie has a separate either substitution, and then they're sort of defined by the Rust def ID enum as the let's see, what is important to talk about here?
So there's some missing types that we need to add to chalk.
Yeah, so once some of these types get added to chalk, it'll be easier to lower.
The built-in ones, obviously. I don't know. Something's like foreign. I don't know how to think about that. That might be not neat. I guess there's this question about whether we want to have a bunch of variants for just like a type name variant that just has a def ID.
Yeah.
But I guess we probably do. But it's still an apply type, is my point. The ones I was thinking about are generator witness in particular, I think it's actually wants to be a fresh kind of type in Java, if not an apply.
Right. Yeah, we talked about that previously.
We should be able to remove unnormalized projection, I think.
Yeah, I think that was only from at least from what I can tell from comments, that was only used for the old implement or old integration.
Yeah, I think
Um,
so.
so I think that can be removed. Um, yeah. So for the most part, these seem like one-to-ones. An important maybe point here that we will talk about when we get down to collect bound bars and the param substitutor is that when we lower, we don't expect params ever because we've already sort of converted them to placeholders or bound bars.
That's probably not totally true. I mean, it's true in depending on what examples we want to do.
So the reason why we can't lower them here to placeholders or bound bars, at least while we are changing them, is we don't know what else is in scope. And so we have to sort of already collect them.
Well, we should be able to convert them to. So, okay, let me give an example where I think we might encounter them. I don't know, something like this. Clone. Why I picked debug, I don't know. So if you had a call like so, right?
Mm-hmm.
Then when we go to prove this goal, T will appear in the goal we're trying to prove. The goal we're trying to prove for this call is going to be that.
Mm-hmm.
This will be a tie param. And we won't have a chance to substitute it because it's free in the goal. This is kind of the case where in that ordinarily we would substitute it because we'll have been pulling some type from a definition and then we can substitute its parameters or whatever, right? But here where it appears free in the goal, I think we would encounter it. And I think we would want to translate it to a placeholder in the root universe with.
Well, so I think so everything does get lowered into placeholders. It's just a matter of where. And I think it will be covered elsewhere. Maybe, I don't know. I would have to double check.
You might be right, just because I feel like tests probably covered stuff like this.
Possibly.
Maybe not.
Maybe.
All right.
Side note, we should probably go through and make a list of tests that we need to cover. Maybe not just for this, but in the future. Because right now, I don't know. I feel like there's probably I don't know, some overarching theme for what each test is supposed to test, but it's not super clear, so we should define that better. Region is similar to tie in that a lot of things are, well, no, the region's more complicated. So maybe the big thing is the early bound versus late bound discussion. So early bound, we like params, we sort of already handle this farther up when we had the context around. And so it'll panic here because it shouldn't show up. Late bounds, we already have an index on that. And I guess, yeah. And it's also important, and we'll cover this later, the early bounds are actually converted to late bounds to actually sort of keep track of an index. But we'll talk about that later.
I don't have too much time.
yeah, what are we at? We're at, we have 9 minutes left. Maybe we should skip down to collect bound vars.
Yeah, it seems pretty relevant. This index of 0 surprises me.
Yeah, that doesn't look right. No, that's not right.
Can't be.
But anyways,
All
so
variables are the same.
say again.
All variables should not be the same.
Mhm. Yeah, that's not quite right. Anyway, so collect bound vars. So we sort of have to do bound var collection in 2 passes. So the first pass, we actually collect them, but in the second pass, we substitute named vars for indexed vars. And we sort of have to do that in the second pass so that the indices that we substitute are after all of the sort of non-named ones.
We should do some examples. Okay, so this bound var collector will find. I don't think this will actually happen in practice, by the way, except maybe in chalk stuff they generated from that chalk. That's another. This was only used for the old chalk integration, as far as I know. But it's something we probably want eventually.
Interesting.
Okay.
Right. So, like, we're still in.
I see. So we did the anonymous ones, the name ones.
Right. So the first pass, we collect the named parameters or the named late bound regions. And then the second pass, we actually do the substitution.
Then we replace them with anonymous ones.
Mm-hmm.
And then we renumber the anonymous ones so that they come after the named ones. Is that the idea?
No, it's the other way around. The anonymous ones stay the same. The named ones come after. I don't know if it matters too much. Either way, it's just, I guess, more simple to do it this way because we can sort of collect ahead of time. And then this is bound param substitutor, and so this is separately. So this is not in the collecting bound vars. This is before we actually lower anything, we substitute the params for placeholders.
So don't we? Something seems funny to me.
I wouldn't be surprised.
I think this should not be early here.
This is named regions.
This is this bound param substitutor.
Right.
And the reason is I think that, if I'm not mistaken, that gets run. So if we jump back, there's like several passes. Where was it? Up here. First, we collect the named. Wait, no. What is this code?
So this is substitute params. You want bound vars collector?
I want this.
Yeah, but yeah.
First, we collect the bound variables.
Mm-hmm.
Then down later, we invoke the substitutor, right?
Right, but this is, so you were looking at the bound vars substitutor, right? Bound param substitutor. The name is awful, but this is what you were looking at was not. Yeah, I should write some more comments here to make it more clear.
Okay. I was also wondering why there need to be 3 passes. There doesn't. In other words, this is a different thing.
Yeah, okay. There's 2. Yeah, because one's to collect the bound vars, and then one, collect bound vars and sort of substitute named ones for anonymous ones, and then the other pass is to substitute params.
Okay. Okay. there is, by the way, what's it called? There's a piece of code that kind of already does this, for a different reason, but is it this code? Yeah, anonymized late bound regions will convert all late bound regions to some incrementing index.
Oh, well, that's good to know.
Maybe I could have mentioned that to you beforehand. And if you use this helper, this one kind of maybe doesn't give you everything you might want. The replace late bound regions function also gives you back a map from what was the bound region to what was the region we created for it. I don't know, maybe you don't need that map actually. The only reason you might want that map, I guess. Okay, so the lazy person's version of this code, I guess, would be that you would call the anonymize, no, I lost track of where it was. Here I am. You would call anonymize late bound regions or whatever. This needs to be a binder T, but anyway. And then that would give you back something with all BR nuns, but then you have to call probably, this is why I say lazy, because it's kind of inefficient, but there's some function, maybe it's not called count, I guess, which will count how many late bound regions there are, and tell you, because you kind of need that number, right?
Yeah.
And you won't get it from this pre-existing function. Or you could write, if you call that, if you look at the way it was defined, it uses this helper that returns a map, and I guess the length of the map would be what you're looking for.
Yeah.
It just doesn't happen to give you that back. This is a pretty handy function.
All right, yeah, I'll look at it.
Gets rid of a lot of boilerplate.
Yeah, I'll look at it.
Notes in the paper. Okay, so the early, but I mean, apart from making the code, a lot shorter, what it's doing makes sense. I would still expect this code, instead of being 0, I would expect you would match.
Yeah,
this must be a BR anon, else you should panic, and it gives you the index, right?
Yeah, that should be changed. I don't think that's an oversight.
I'll just
though, yeah, I think the only reason that it hasn't come up where I haven't fixed it yet is because it hasn't mattered so far for tasks, but
yeah, maybe good to make a test first.
Yeah.
But, so this other one, I guess we're gonna have to go soon, like now. But
yeah,
this other function,
it's
substitutor,
right,
or whatever calls param substitutor.
Yeah.
Which is, I guess, up here somewhere.
Yeah.
This is it.
Yeah, substitute params.
Where does that get called from?
I don't remember if it's called from here or if it's just DB.
From the DB. Okay, that makes sense.
Yeah.
Yeah, that's the other big chunk of code we didn't talk about at all. But...
Yeah. And this, yeah.
So when you get, but okay, let's look at one of these random things. People datum say. We're gonna pull out the def ID. We're gonna call bound vars for item, which is gonna make a mapping from the parameter to, well, I guess here you're gonna use bound tie, so you can't move it. Which is fine. Okay, and then it's going to map. I see. So it's mapping these to late bound. Okay. Yeah, that makes sense. Okay, so it's going to map from the rustc style into bound versions, basically. And then we get something from the def ID. We apply this. So now we have it in bound versions.
Mm-hmm.
Okay. And then I'm not sure what the role of, well, at minimum, I would say at this point in this code, then, assuming everybody follows that pattern, there should be no early bound regions because you just substituted them away.
Maybe. I would have to double check.
I think that's true. If it's not true, I think it's a bug somewhere else.
All right.
Or else some of the code is following a different pattern, but I think that's the right pattern. It's kind of the definition of an early bound region is that when you call subst, you will substitute.
Yeah. Yeah. Yeah.
But you are correct that, well, it's actually not the case. So there should also be no late bound regions in this particular case because impls don't have late bound regions. Those only appear on function items, which you probably are just not going to interact with at all. So you can probably just delete this substitute params, or make it much simpler, because also bound vars for item like could return to you the list of parameter kinds, right? It's creating all the, or we could get it from other places. Does that make sense?
Maybe. I need to think about it a little bit more.
Okay. So just, I don't know if you've, did I ever point you at like the blog post that talked about why late bound regions even exist?
Yes, I think so. Maybe.
It may not even be readable, but I mean, a late bound region in any case only applies to one like this,
right,
where it appears only in the types of the parameters,
Mm-hmm.
or it can appear in the return type also, but only if it also appears in the parameters and not in any where clauses. And in that case, it's like, you know, it's a type that would be bound in the type when you reference this thing.
Right.
So it's just not really, the concept just doesn't really apply to impls. Kind of. Now let me decide if I'm lying to you. I think that should be true.
Yeah.
So the last thing I'll mention then while we're doing this is that there's a, what's it called, binders? No, it's called generics. There's a, oh, I see. Where is it? This, no. Maybe it's been renamed. I don't think so though. So there's this. This is the one I want generics of. What is that? Generics. Okay. So what you could do to get the parameter kinds, either you could build them in here,
Mm-hmm.
or you can invoke this generics of with the impl def ID. And what that will give you is a tie generics, which is basically a listing of all the generic parameters.
Okay.
It's kind of a wacky data structure. It's got some structure to it to tell you the scopes and so on, but it's got some methods, presumably, that, I don't know.
Yeah.
I guess you can get things from it.
Yeah. A lot of this I copied from the old implementation. But
yeah, I'm basically contending that this could just get simpler, I think. I'm not saying it just so it is the wrong thing.
Yeah. Yeah, I'll have to try to run it without substitute params. In some cases,
I
it
feel
gets a
like
little tricky because I think I use read late bounds in cases where it might not even be needed or wouldn't normally be there because it has the index. But I don't know if that's true.
I don't know if I understand that, but I'm not sure which index you mean.
Well, because the read late bound has both the Debrugen index and then also the index on in the universe or in the yeah. And so we can convert it directly to a chalk bound bar or bound tie. Whereas I don't know, do any of the other regions have both a Debrugen index and an index on
Well,
in
but
that?
you know that you want to convert it to the innermost binder here, right?
Yes.
And then subst will do the right thing in terms of adjusting the binders in case that it's substituting into something with additional binders in scope.
Yeah.
So I think you can just kind of like replace some of these things with .subs and the code will just get shorter. So otherwise
Yeah.
it looks like it's pretty much doing the right thing. Building up the little structures. We're not doing any caching, but who cares? It's not worth. That's not.
Yeah. No caching, which makes it easier.
Doesn't make sense to cache at this point.
Mm-hmm.
Do you? All right. So I should probably go, but
Yeah.
do you want me? So I left some notes. I'm going to push this random edits.
Yeah. If you want to push those, I'll look at those.
And if it's confusing what I'm saying, I could go and try to convert just one of these functions to see what I'm, just to show you what I think it would look like, and
Yeah.
that might help make it clearer.
Yeah. I mean, if you have time, feel free to. Otherwise, I'll try to get to it at some point and just play around with it.
But this is cool. It's basically there. It's really neat.
Yeah. It's getting there. How long have you been working on this? A month or so? But,
it's not that long.
Yeah, it's not too bad.
Some of the early chalk blog posts, and I was like, oh my god.
Oh yeah.
I don't even know how many years. On and off. Maybe finally we'll actually get it done. All right. Well, thanks everybody.
All right.
Talk to you all
Yep.
later.
Thanks for joining.